This is a continuation on our video on functions. So in this part of the section, we're going to talk about how to determine if an equation is a function or not. And not all equations are functions, right? And that's what this really says here, right? So not all equations are functions. An equation is a function if when solving for y, only one output would occur for a given x value. So if you subbed in an x value, you'd only get one answer out for y. So we're going to do some examples here where, I'm going to give you an equation and we're going to determine if y is a function of x or not. Meaning for every x value, there'd only be one y value. So let's take a look at the first one. So let's say I gave you x squared plus y equals 4. We want to know, is y a function of x here? Well, we can solve for y, right? So I'm saying solve for y. I'm going to subtract x squared to get y by itself. So minus x squared and minus x squared. I end up with y equals 4 minus x squared, or I could write it as negative x squared plus 4. Either way is okay. And then you want to determine, okay, is this a function or not? Well, think about what happens if you substitute an x value in. If I substitute an x value in here, right, how many answers do I get for y? So suppose I subbed in 1, for example. I have 1 squared would give me 1, negating that would be negative 1 plus 4, was give me a positive 3. I'd only get one answer out. So when I substitute an x value in, I'm only going to get one answer out each time. So the answer here is yes. It is a function. Right? Each x value only gives one y value. Alright, because when you substitute into this, you only get one answer out for each x value. How about this one? If I said I had x squared plus y squared equals 1. So again, the first thing we're trying to do is we're going to solve for y. To solve for y, I have to isolate the y terms. I'm going to subtract x squared from each side. Similar to what I did in the last example. So I'm up with a positive y squared, which is just y squared, equals, I'll write this as 1 minus x squared. All right, you can write it as negative x squared plus 1 as well. Now we haven't solved for y yet. We also need to take the square root, right? How do you get rid of something that's squared? You take the square root of each side. When you take the square root, though, if you write the square root, remember you have to write plus or minus in front. And we mentioned this before. So you end up with y equals plus or minus the square root of 1 minus x squared. Something to point out, you can't take the square root of each piece individually. Remember, you only can do that if it's multiplication or division inside of a square root. If it's addition or subtraction, you kind of have to leave it. So what happens here? Is this a function, yes or no? Well, for every x value I substitute in here, how many y values am I going to get out? Well, the plus or minus tells me it's two answers. For example, if I subbed in x equals 0, right, I get 1 minus 0 squared, which is 1 minus 0. So I get the square root of 1 here, which would just be 1, but it's plus or minus 1. So when x equals 0, right, the y value would either be a positive 1 or it would be a negative 1. So there's more than one answer there. The plus or minus is really what's indicating this to you. So the answer is no, right? It's not a function. And the reason is because there are x values that give two different y values, right? Remember, each x has to have its own y value to be a function. So if it does in this case, then it's not a function. The plus or minus is really what's tipping you off to that. And a lot of this, can be seen through the exponents, right? This y here is a odd exponent. If there's an odd exponent, you're not going to get a plus or minus when you solve. If you have an even exponent, you would get a plus or minus when you solve when you're taking the roots. All right? So that's something to keep in mind. If you have an even exponent, when you take the root of that, you're going to get a plus or minus out. How about this one here? If I said I had x squared plus 5x plus 3 equals y to the fourth power. Well, based on what I just said a moment ago, right, if you have a fourth power on here, really what that's telling you is that, you know, this could have a positive or a negative answer. And if it does have a positive or negative answer, you could tell me right away. If the power is even on this, then no, it's not a function. Right? Because for a given x value, you could have more than one y value that satisfies this to be an even power. In other words, you would solve this by taking the fourth root. When you take the fourth root, you should be indicating that it could be a positive or negative to give you this y. So, no, it is not a function, because you have to put a plus or minus when you're taking an even root. How about if I asked you about this one? If I wrote y equals the absolute value of x. Now, this is a little different because it's not a polynomial. But when you look at this, you should know what the absolute value function looks like. But let's, do a quick sketch of it here. The absolute value function, if I was talking about y equals the absolute value of x, here's x and here's y. Think about what happens when x is 0, y is 0. If x was 1, then y would be 1. So you'd have, 1, 1. If x was 2, the absolute value of 2 is 2. So you'd have this piece here going like this forever, right? If x was 3, it'd be 3. If x is 4, it's 4. You've got this line wherever y, in the positive side, right, whatever x value is, y is equal to that x value. Now on the negative side, let's say x was negative 1. The absolute value of negative 1 would be positive 1. So you'd be at the point negative 1, positive 1. The absolute value of negative 2 would be positive 2. So you'd be here, and so on. The absolute value of negative 3 would be positive 3. So the shape of the absolute value function is a V. The way you write this function piecewise, and we'll talk about piecewise a little bit more in a minute, is y is equal to, we can say it's equal to x when x is greater than or equal to 0, right? This part of it here, right? When we had x was 1, y was 1. When x was 2, y was 2, but that's only for x's that are bigger than 0. It's equal to negative x for the x's that are less than 0. In other words, when I had negative 1 for my x value, negative negative would make it a positive 1. Negative negative 2 would make it a positive 2. So this is another way of writing the absolute value function. But the point being here, is this a function? And I've said function a few times, so you should know the answer is yes. But the reason it's yes is that, right, each x value is only going to give me one y value out. Right, so yes, we'll say it is a function each x value is associated with only one y value. So just making sure you understand where that comes from. Something you might see that's similar but different. Maybe I'll write it on the same page. Maybe I can fit it down here so I can compare the two. What if I said the absolute value of x equals y? Oh, I'm sorry, I wrote that incorrectly. What I really wanted to say is, what if I said the absolute value of y equals x, right? The absolute value of x equals y is what I have. Y equals the absolute value of x. So the absolute value of y equals x. When I look at this, think about what's happening here. It's kind of the opposite of this scenario, right? When I have the absolute value of x equal to y, then y is equal to either positive x or negative x, depending on where you were, for the x is greater than 0 or the x is less than 0. In a similar way, you could write this for the absolute value of y is equal to x, right? Thinking that x is equal to, well, it's equal to the positive y values for when y is greater than or equal to 0, and the negative y values for when y is less than 0. It's the same thing here, we're just switching the variables. But what this really shows then, if you were to graph this, is that, when x, or when y is 1, then x is 1. When y is 2, x is 2, and you have this piece, and you have this piece here. And this is the graph of x equals absolute value of y. All we're doing is switching the x and y values, right? So when you think about this compared to the one we did prior to it, you're switching the x and y values. But when you're taking the absolute value of y, what that's really saying is that there's two values in here that will give you the same x value, right? When y is 1, right, x will give you, it'll come out to 1. When y is -1, x will come out to 1. So the x value of 1 has two different y values that go with it, either a positive 1 or a -1. So you don't even need to draw the graph, you can just have an understanding of what happens when you substitute in, but the answer here is no, it's not a function. All right, each x value other than 0 has more than one y value associated with it. So you could also have noticed that if you did the vertical line test on this, it would intersect twice, and that would also tell you that it's not a function. So when you have absolute values on the x's, typically those will be functions. You have absolute value on the y's, then it will not be a function. The last part of this piece of the section, we're going to talk about function notation. So I'll do this through an example, but if I said evaluate each below, given that, I'm going to write a function here. I'm writing in function notation. So I'm going to write f of x equals x squared plus 3x minus 5. Now when I say f of x, you might not be familiar with this. You may have seen it and you're not sure. This is an x value substituting in. F of x is really the y value. I could have written this as y equals x squared plus 3x minus 5. So f of x is the y value associated with this x value. It's saying take this x value, substitute it in here, and you'll get a y value out. Remember, the x values are our domain, the y values are our range. So if I was looking at, let's say, f of -2, what it's really saying is take the x value of -2, substitute everywhere in here, and then get whatever the y value that corresponds to it out. So let's substitute in. When I substitute in x squared, x is -2, so it's -2 squared. Make sure you're squaring the whole -2 in parentheses like that, because that's what x is. X is the whole -2. That's what's getting squared. Plus 3 times -2 minus 5. We can simplify this term by term. -2, the quantity squared is a positive 4. Positive 3 times a -2 is a -6, and then minus 5. So 4 minus 6 is -2, minus 5 will give me -7. So f of -2 is equal to -7. The x value is what you're substituting in, the y value is what you're getting out. If I was thinking of this as an ordered pair, it'd be -2, comma, -7. Now, unless I ask you for the ordered pair, you wouldn't write it that way. You'd write f of -2 equals -7, just understanding that the x value is what is being substituted in, the y value is the result, the -7. Let's take a look at something a little more complicated. If I wrote f of x plus 1, sometimes people get thrown off by this kind of thing. What this means is what? It means substitute x plus 1 everywhere you saw an x in the original function, just like this meant f of -2 was everywhere you saw an x in the original function, you're subbing in -2. So here, everywhere I see an x, I'm subbing in x plus 1. So here, x squared would really be x plus 1 squared, and you have to square the entire thing, make sure you have the whole thing in parentheses, plus 3 times, replacing x with x plus 1, and then minus 5. And now we want to expand this, right? That's how we're going to simplify it. Now x plus 1 quantity squared, make sure you understand this does not mean square the x and square the 1. That would be incorrect. What it really means is take this and multiply it by itself, right? It really means x plus 1 times x plus 1. All right, and then here, plus 3 times this, you can distribute the positive 3, so plus 3x. Take the sign with it. A positive times a positive makes a positive 3 times 1 is 3. And then -5 is just -5 at the end. We're not distributing there. And how do you simplify this? Well, here, when you have a binomial times a binomial, you FOIL this. We've talked about this in the past. X times x is x squared. The outer would give me x times 1 is positive 1x. And the inner gives me another positive 1x, so this would be plus 2x. And then plus 1 times 1, which is plus 1. And then plus 3x plus 3 minus 5. And then let's combine like terms here. So this will give us x squared, will just stay x squared. A positive 2x plus 3x is plus 5x. A 1 plus 3 is 4 minus 5 gives me negative 1. So I have f of x plus 1 is equal to x squared plus 5x minus 1. Now you wouldn't write it as an ordered pair like we did up here. This is just to show you this is the x as the y value. Here the x plus 1 is what we subbed in. The x squared plus 5x minus 1 is what we got out. Let's try a couple more. If I said I had f of negative x, well, that's equal to what? Take negative x and you're substituting in everywhere you see an x in the original problem. That's what it really means. So substituting in for x squared, right, we'd have negative x squared plus 3 times x. Now it's 3 times, subbing in negative x, so it's 3 times negative x. Make sure you put the parentheses. It doesn't mean 3 minus x, it means 3 times a negative x. And then minus 5 stays minus 5 since there's no variable piece to it. Simplifying this, negative x squared, well, negative squared gives me a positive. X squared is going to be x squared, so it's positive x squared. A positive 3 times a negative x makes this a negative 3x and then minus 5. So f of negative x is equal to x squared minus 3x minus 5. Alright, so you can substitute variables in like that. Later on in math, this becomes important, understanding how to evaluate that. If I said negative f of x, this is different. This negative is on the outside of the function, right? The previous negative was on the inside of the function. This negative is on the outside. So f of x, remember this whole thing is f of x. So if I take negative f of x, I'm taking negative of the whole thing. So it's really negative, and then in parentheses, x squared plus 3x minus 5. Right, that's just us taking the negative of f of x, the negative of the whole thing. And then if you simplify that, this will give you negative distributed through. Negative 1 times a positive x squared is a negative x squared. A negative 1 times a positive 3x is a negative 3x. And it's like a negative 1 times a negative 5, which makes it a positive 5. So you get negative x squared minus 3x plus 5. That'll be another important thing to be able to evaluate. Negative f of x means just take the negative of the function. You're not changing the x values. You're actually taking negative of the whole thing and then distributing it through. And the last one we'll look at is a piecewise function. So let me give you a piecewise function here. So for example, evaluate each given that. Now I should mention this here. When I called this f of x, f is just the name of the function. So this is, you know, a function of x named f, but it could be anything. Like we have g of x, h of x, you know, a of x, whatever you want to call it. Typically f of x is what we use, but you'll see f, g, and h the most common. So I'm going to call this next one g of x. Remember, that's just the name of the function. It's saying the x value gets subbed in, g of x is the y value that comes out. But I'm giving you a piecewise function here. When I say piecewise functions, they have different values for different parts of the domain. So if I said g of x equals x squared minus 2, I'm saying we're going to only use that for when x is less than negative 1. So you're going to use that part when x is less than negative 1. I'm going to say 3x plus 1 for when x is equal to negative 1. And I'm going to say the square root of 5x plus 5 for x greater than negative 1. So the way piecewise functions work is that if I give you this piecewise function, depending on the x value I'm using, it takes on a different equation. So let's see if we look at this one here. So if I call this one g of 7, what does that mean to do? Well, it really means take this x value of 7 and you're going to substitute it into our function g of x, right, to get the y value out. Well, which part of this does 7 fall in, right? 7's an x value, so you're looking over here. Where is 7 going to fall in? Which interval? Well, x is greater than negative 1 is where 7 would fall, so I'm going to use this one here. You don't plug into all of them. You only plug into the one where it applies. So for x being greater than negative 1, that's where 7 falls. That's why we're using the bottom one here. So this is equal to square root of 5 times, substituting for x now, because we know what it's supposed to be. It's supposed to be 7. So it's 5 times 7 plus 5, which equals the square root of 5 times 7 is 35 plus 5, which is the square root of 40. And then don't forget, we're still going to simplify this like we have in the past. So square root of 40 is not a perfect square, but you can separate it into its highest perfect square factor and a non-perfect square factor. Highest perfect square factor is 4, the non-perfect square factor is 10. So the square root of 4 times square root of 10, the square root of 4 gives us 2. We keep the square root of 10 because it doesn't have any perfect square factors other than 1. And 2 square root of 10 will be the exact answer. So g of x, or g of 7 I should say, is equal to 2 square root of 10. So the x value of 7, the y value that goes with 7 is 2 square root 10. Right? Make sure you keep it exact. Exact means keep it with the radical in there. How about we look at another one? G of negative 3. Make sure we understand what we're looking at. G of negative 3 is telling you that x equals negative 3. Well, which interval has x equals negative 3 on it? Well, when x is less than negative 1, that's where negative 3 would fall. So you're going to use the first function. You don't use all of them, right? It's very specific. It's telling you when to use it. Right, so x is less than negative 1 is where negative 3 would fall. So we're using the x squared minus 2. Now you know what x is. It's negative 3. So substituting negative 3 squared minus 2. Make sure those parentheses around the negative 3. It matters. If you don't, it means something different. Right, this means negative 3 times negative 3. If you just put negative 3 squared without parentheses, it would mean take the 3 and square it and then make it negative. So the order matters on that. You need parentheses. Well, negative 3, the quantity squared, gives me a positive 9, because negative times 9 makes it a positive. Minus 2, 9 minus 2, well, that's equal to 7. So the x value of negative 3 has a y value that goes along with it, which is 7. In other words, a point negative 3, 7 would be on this graph. This is another way of thinking of that. And lastly, if I said, let's find g of negative 1. Well, for g of negative 1, you're taking a look at, okay, which interval has negative 1 on it? Well, in this case, x equals negative 1 has its own point. So this is the x value, right? This is x equals negative 1. That's what that's telling me. Find the y value. Well, we're using 3x plus 1, so it's 3 times x, which we know what it is. Make sure you sub it in. 3 times negative 1 plus 1. 3 times negative 1 is a negative 3 plus 1, which makes this negative 2. So when x equals negative 1, the y value is negative 2. In other words, the point negative 1, negative 2 is on the graph. And that's important to understand. Remember, when you're using piecewise functions like this, you're only using, one piece at a time. You can't, substitute 7 into all of these, or negative 3 into all of these and expect to get the answer correct. Right? You really are only substituting into the interval, or to the function where the domain is listed that contains the x value you have. Right? X is less than negative 1. X equals negative 1, x squared negative 1 is telling you which of these to use for where the x values fall. So hopefully this helps the understanding of functions. The function notation is probably the most important part of this last part of the section. In the previous parts where we talked about domain and range, those are important throughout math as well. So make sure that you have a good understanding of this before moving forward.